the last presentation we completed the Moore state machines, and now we are going to do the Mealy state machines or Mealy circuit. If you remember, I told you the main difference between these two types of model or these two types of circuit is the way the output is generated. Okay, and in case of Moore state machines, the output was the function of only the present state, whereas if I talk about the Mealy state machine, the output is the function of present state as well as the input. So this is a very important point to remember. And I also explained you this block diagrams, in which the first one is my next state decoder. Depending upon this logic, the next state is decided, and there is an input. Let's say this input is A. We are giving this A to this next state combinational logic, and the output of this combinational logic will decide the next state, and this is my memory block, and the present state is stored here. This whole block diagram is for the Moore state machine, and you can see the output. Let's say output is Y, is the function of the present state only. To make it Mealy state machine, I need this output as the function of the present state and also the function of the input, which means A. So there is a small change. To make it the Mealy state machine, I will take this input from here, and I will give it to this output combinational logic. Now you can see the output is the function of the present state as well as the input. So this is a Mealy state machine. Now we will see one example related to the Mealy state machine. I will take the same example as the last one, and I will do a small change to convert it to the Mealy. And let me paste it down. We will drag it to the bottom of the board so that we can analyze it peacefully. Okay, and this is the same example you can see from the previous lecture, and the change that I'm going to make in this circuit is to make this output Y the function of A. So I will take this A from here like this, and I will give it to this OR gate. Now you can see that the Y is what? Q B complement. This is QB complement, and QA is the another input. So OR QA or A. Now this output is the function of the input, and also it is function of the value stored in the flip-flop. So we can say that it is the Mealy state machine or Mealy circuit. So once you have the idea about the Mealy and the Moore state machine, basically the difference between them, it's not a big deal to do these things. You can easily get by looking to the circuit diagram and also by looking to the state diagram that whether it is a Mealy state machine and whether it is a Moore state machine. And there are some questions in which it is especially specified that we have to consider it as the Mealy or we have to consider it as the Moore. That's why it is an important topic before actually going further to solve the problems related to the state diagram. That's why I completed it here. In the coming presentation, we will do the analysis using the JK flip-flop, D flip-flop and T flip-flop. Then we will see the sequence detector or pattern detector. So these all topics are very important and carries a good weightage if you are preparing for any exam. There is one more point that I want to tell you is the implementation of a logic function needs more number of states than Mealy circuit in case of Moore circuit. Okay, so I can also say it as the implementation of the same logic function requires less number of states than the Moore circuit. So in Mealy, the number of states are less as compared to the Moore circuit if we are implementing the same logic. So this is what I want to tell you, and I will end this lecture here. See you.